Hi and welcome to Math Foundations 20. This is section 5.4, just a video about what the normal distribution is. Okay, so in class we were looking at rolling two dice and we said that that would be what we call a normal curve. So basically, what is a normal curve? Well, a normal curve has this sort of bell kind of shape to it, or one peak, one mode, a mound kind of shape. Okay, and so what that shape tells us, right, is since it's symmetric, it means that on one side and on the other side, all of the same amount of data lies on each side of it. Okay, and other things this shape tells us is that for values at this end, they occur very infrequently. Values at this end occur infrequently. Values in the middle occur the most frequently. So for example, when we rolled the two dice, right, getting a 2, right, happened very infrequently. Getting a 12 happened infrequently, but getting a 7, right, happened the most. Getting an 8, a 6, right, we're up there too. Okay, so not all distributions are normally distributed. All right, so we know that rolling one die isn't normally distributed. So it's not that everything fits this, but some things do. Okay, so more specifically, if something is normally distributed, we've got relationships about those things that we want to know. So basically, the peak of the normal curve, right, so this here is located at the mean of the data. And when we're doing normal distribution, this new symbol here, the mu, that will represent mean. So instead of x bar, it's written as mu for these sections. Okay, so that's the peak of the data. So the peak occurs at the mean. Okay, other things is that if we go up from the mean one standard deviation, so depending on your data set, that standard deviation is going to be different, but if we go up one standard deviation, 34% of the data lies from the mean to one standard deviation above. And then also, since it's symmetric, 34% of the data lies from the mean down one standard deviation. Okay, so that also means, as we say here, 68% of the data is located within one standard deviation. Right? That means from the mean, if we go up and go down, those 34 and the 34, that's 68% of the data. So basically, things that are normally distributed have most of their data, or not, well, most, yeah, 68% of their data, right, in this area here, close to the mean. Okay, and then we also have information about standard, or if we go up 2 standard deviations. So basically, if we go from the mean up 2 standard deviations, we've got 34% in here and then 13.5% in there. So if we go from the mean up 2 standard deviations, that's going to be 47.5%, and then the standard mean down 2 standard deviations is another 47.5. So from here to here, right, that's 95% of our data. So basically, if something's normally distributed, 95% of the data is within 2 standard deviations. So almost all of the data is within there. Okay, and then if we keep going, right, we go from here to here. That's 99.7% of the data is within there. And another thing about the normal curve is that all of these under here, right, they'll obviously add up to 100%. And if we talk about an area, it has an area equal to 1. Right, so again, this is something that's going to hold for every set of data that is normally distributed. Not every set is, but for ones that are, basically we're going to be able to use these percentages to answer problems. So that's what we'll look at in example 1 in the next video.